Hello everyone, my name is Rajesh and I am from 4th BTech CSCA, and here we are going to explain three topics in fundamentals of blockchain, and my sir is Ravindra Reddy, Assistant Professor Anurag University, and presented by Rajesh, Rohit, Sangu Navin, Nitin, Sandeep, Kartikeya and Shashank. And we have three topics, and they are block in blockchain, layers of blockchain, and a smart contract on will of a person. And I am going to explain block in blockchain. A block in blockchain is essentially a container. It contains a data and a record of several transactions, along with header, and that includes important information about the previous blocks and as timestamp and nouns. The purpose of block is to provide a secure way to share transactions between the blocks in a blockchain network, and it's a linear sequence, and it produces immutability and transparency of blockchain is maintained. And the components of blockchain. There are three components in blockchain, and they are header, a list of transactions, and hash. Header consists important information like previous blocks, hash, timestamp, and norms. The list of transactions includes all the data being recorded on the blockchain, such as cryptocurrency transactions. And the hash is a unique identifier for the block, and it is generated based on the data in the block. Hashing and hashing and the block. Hashing is the process that takes any size, produces a fixed length output. It uses to ensure the integrity and security of data in block. A block, on the other end, is a collection of data that is added to the blockchain. Each block contains a unique hash that connects to the previous block, forming a chain. This helps maintain the immutability and transparency of the blockchain. Mining block. In blockchain, mining involves the process of adding new blocks to the blockchain. Miners use powerful computers to solve computer mathematical problems, which validates and verify transactions. Once a miner successfully solves the problem, they add the new block to the blockchain and are rewarded with cryptocurrency like Bitcoin. Mining helps secure the network and ensure the integrity of the blockchain. Block size and scalability. Block size and scalability are important considerations in blockchain technology. The block size refers the maximum amount of data that can be included in a single block. Larger block size allows for more transactions to be processed at once, but it also increases the storage and bandwidth requirements for running a node. Scalability, on the other hand, refers to the ability of blockchain network to handle the increasing number of transactions so the user base grows. Various solutions such as increasing block size, implementing off-chain transactions, or using layer 2 solutions are being explored to address scalability challenges in blockchain. Future of blocks in blockchain. As blockchain technology continues to evolve, the concept of block may also see changes in order to meet the needs of new use cases and applications. The future of blocks in blockchain looks promising. As technology evolves, there are ongoing efforts to improve scalability, such as implementing layer 2 solutions. Additionally, advancements in consensus algorithms like proof of stack aim to make blockchain more efficient and sustainable. These developments will likely lead to increased transactions throughput and improve scalability in future.
Hello everyone, my name is Naveen. Today I am going to discuss about layers of blockchain. Blockchain technology consists of several layers that work together to provide security, transparency, and decentralization. There are five main layers of blockchain technology: the network layer, consensus layer, application layer, hardware layer, and data layer. Network layer. This layer deals with the communication between nodes on a blockchain, means it will be providing communication to the nodes. Since blockchain is an open system, each node has to know about the transactions which other nodes are doing. because the network layer enables this communication. This is the foundation layer of the blockchain, and the first layer of the blockchain comprises a network of nodes that communicate with each other to maintain the blockchain's integrity. Nodes can be miners, validators, or simply participants in the network. Consensus layer. This layer is responsible for achieving agreement among nodes on the states of the blockchain. Different blockchain use various consensus mechanisms such as proof of work, proof of stake, delegated proof of stake, etc. to validate and agree on transaction. Consensus layer is majorly depend on an agreement on each nodes. This layer is the one responsible for validation of a block. Let us understand the consensus layer using an example. There are two persons, John and Mark, and they are the two validators on the blockchain. They receive transactions which have to be decrypted and added to a block. First transaction, John receives are A and B, and transactions Mark which receives B and C. If both John and Mark validate the transactions and add them to the blockchain, then transaction B will be written twice on the blockchain. This means double spending will occur. To avoid this, John and Mark compete and solve a cryptic mathematical puzzle, and the one who solves first will be the one to add to the blockchain. This form of consensus mechanism is known as proof of work. Application layer. Application layer majorly used for building the applications. These applications can be anything like wallet, social media apps, browsers, and NFT platforms to name a few. While the UI and UX of the app is just like another normal application, the difference is the decentralized nature of data storage at the back end of these apps. The topmost layer is the decentralized applications built on the blockchain. The apps interact with blockchain's lower layer through application program interfaces to access and modify data and smart contracts. Hardware layer. Blockchains are based on peer-to-peer information sharing. The network of computers which contribute to the computing power of the blockchain from the hardware layer. Most importantly, blockchains are a summation of all the nodes which makes them. A node is a computer or a network of computers which decrypt transactions. The hardware layer is essential for the performance, security, and reliability of blockchain network. The choice of hardware components and their configuration can vary depending on the specific blockchain's consensus mechanism, scalability requirements, and use cases. As technology advances, new hardware solutions and optimization may emerge to support blockchain network more effectively. Data layer. This layer is used to store the data where details of transactions are stored. The transaction stored on a blockchain has details of crypto sent, the public key of the receiver, and the private key of the sender. Each block which has data is connected to the previous block and the next block which is generated. Only the genesis block, the first block of the network, is connected forward and not backward. The data layer is the core layer of the blockchain's functionality, and it ensures that the ledger means all the transactions history will be stored on this layer, which is secure, tamper resistant, and transparent. Different blockchains may have variations in how they structure and manage data, but the principles of immutability, transparency, and cryptography security are common across the most blockchain implementations.
Hello everyone, I'm Sandeep. The topic is about the smart contract, about a will of a property. So generally, we in daily life we do write property wills for physical property and things, money that we have. So this smart contract is all about just the same property, but like the property in the blockchain. So it's it's legal, but like writing will and for a property in blockchain is this code. So in the second line we can see that pragma solidity, that's a version. So 0.8.0 is a version. So this pragma solidity version enables us much inbuilt functions. And then we do have this contract name property will. And in this contract, we do have three variables: owner, beneficiary, and will created. Owner and beneficiary are of type address, and will created is of type boolean. So like boolean can be true or false. So here we can see that even will created address indexed owner, address indexed beneficiary. Two parameters it's carrying. So we do speak about it in the last. So now let's go to constructor. So we all know that constructor is only executed once when the contract is created. So here the contractor owner equal to message sender. So that means the one who first executes like this contract will be the owner, and will create it is false because in the first execution they doesn't create a will. Only if they call the function, then the will is created. So the constructor is there, so the owner is fixed for the first time. Like we all know that constructor once executed, it's the same thing, like it can be only executed one. So now this is the modifier only owner. So this thing is like every time the owner logs in again, so it checks whether the message sender is owner. So if it's not a owner, they cannot execute this. Only the owner can be executed. So modifier will not create it. So if the will, if the will is created, then the will cannot be again created. So the will once created can be stopped, or it cannot be done anything. Like it can be acquired. So here we can see that function create will. So this carries address beneficiary, address of the beneficiary. Public only owner will not. So these are the modifiers that we have seen above. So if these are true, only then the function will be executed. Like you can see that this function carries the address of beneficiary. And then if the modifiers are only true, like if that doesn't generate any error, only then the function will be executed by the owner. So the beneficiary is assigned in the first line, then will created is true because the beneficiary is assigned, the property can be on their name. So emit will created owner comma beneficiary. So this line will evoke this emit will created owner and beneficiary will create. I mean will execute this event will created. So what does this emit and event will do? So these emit and event will notify all other nodes in the blockchain that the will has been created in the name of the owner to the beneficiary. So it's it's a public thing. It's notified to all the nodes in the. We can see another function revoke will public only owner. So this makes that if the will is created, then the will the beneficiary can be some zero address of zero. There is no beneficiary for this. Like they want to change their will from one person, from one node to a zeroth node. They don't want the will to be made on their name, so they just made the address of zero. And will created is false because the will is not now. It's like the will is not created. Like the will is created, but it's it's made worthless. So this is about the smart contract. Now we can see that here is the compile. So first we should compile this property will, then compile and run. This remix ID only execute JavaScript program, so it doesn't work with this. So we cannot run here. So now I have already deployed this version of this code. I'll just deploy it again. So you can see that you can see an output here on the screen where just look at this. So here is the total. Here is for the total smart contract status. It's a true and transaction mined and executed. So the state of this status tells us that the transaction is failed or success. Transaction hash. This all details about the smart contract. Transaction hash, block number, contract address from to. So this will from whom to whom. So from and to. So from the address of the owner to the property will dot constructor. I said you that the constructor is only executed one. So it will go to the property will dot constructor first constructor. Then transaction cost, how much transaction cost took place overall. Execution cost, how much cost for execution. Input decoded input. This is a sample code, so we just don't have. So here you can see deployed contracts. So here we do have all functions. So we have to paste the address of beneficiary. We just we'll just copy this address. And we'll just paste this, like this is the owner's address only. It doesn't add it's a sample code. Just to create will. The will has been created. So we can see for how like for each function how like the execution cost and from whom to whom, and the transaction and the execution cost, transaction cost. So it's different for each transaction. Then revoke will, so it is made to 0. So now true transaction executed. So it's like property dot revoke will. So it's the same address that so this beneficiary owner and will created. Like let's just create will. So just we'll try. So now see who's the beneficiary. So just see, you can just see from whom to whom. So as you can see here, who's the beneficiary and who's the owner. So it's just the thing. So here you can see, right, 0 address of beneficiary. So the output like, so the owner, who's the owner of the these are the modifiers that you have seen. Owner and beneficiary, owner and beneficiary are the variables and will created. So it's will created true or false. So these are the variables in the these are the variables in the smart contract that you can see is true, like what is the value at the end of the code. So thank you